The talk is called High and Lowlights of Adopting Nix at Looker. And the rest of the talk will make clear what this is about. Reset my time. I know, I just want to. Cool. So our goal really is not to wow you at all with the setup that we're about to talk about. And it's not exemplary in any way. There's nothing fancy about it. But really, it's to highlight what I would expect to be a very run-of-the-mill use of Nix, and maybe to encourage you to adopt Nix at your company. So, like, that's the goal. You're not going to see anything mind-blowing here, nothing shocking. In fact, probably a lot of the same stuff you might have just heard in some previous talks, but we're doing it in an enterprise setting, and we found doing the most boring, flavorless thing proved to be pretty useful. So that should be words of encouragement for you, because some of Nix can be pretty daunting, and even without all that stuff, it was a boon. Yeah, an interesting product. So yeah, we work at Google. We'll mention that in a sec. They have a huge sizable team that works to build amazing tools to improve the developer productivity. We came in through an acquisition, which we'll also describe. We didn't have access to any of that. So we had to kind of fend for ourselves, build a CI system, developer experience that we wanted to use that was actually friendly, and kind of like that's what this talk is geared to. Obligatory. Our opinions are of our own and not of those of our current overlords, Google. Finally, this talk is going to have high and low lights. Our hope is to be fair. It's overall a positive talk, but we're going to just share some of the sharp points we faced adopting Nix. You can jump in anything.
Yeah, let me just add one thing to that. Farid already mentioned that the team we're working on, Looker, is a standalone product that is hosted in Google Cloud, but it doesn't build with the same technology stack as the rest of Google, and we don't have a dedicated build tools team. So the same engineers that are working on the JavaScript front end and the JVM back end are the same people who might work on the build. So we needed to have some sort of situation where we could control our own destiny and solve problems that couldn't get solved in the central places because of the exceptions we had to be using. So anyway, this is good because a lot of you guys are probably also in companies where you don't control the entire build chain from the beginning to the end, especially if you're split up, in different sub-teams or an ops team and a building tools team. So anyway, that'll be a central theme.
Cool.
Yeah.
Why do we feel privileged to give you this talk? So first of all, my name's Farid Zakaria. I'm an engineering manager at Google working at Looker. I've been using Nix, I don't know, 6 years, 7. It's honestly on and off because it works really well. So I'll set something up and not touch it for a year. So I've been using it for a while, but not actively all the time.
Yeah, and my name is Micah, Catlin. I'm a software engineer, and I've been working at Looker for a really long time before it was acquired by Google. So I'm partly responsible for some of the terrible hacks that we now are committed to.
Okay, so I mentioned we worked at Looker. It's a SaaS business. It's a SaaS business intelligence product that works very, 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 very well with BigQuery, along with some other big databases, but primarily BigQuery, which is not a shock. Honestly, Looker itself is not really important to this talk. We're going to really talk about the technologies we've used and how we used Nix to kind of bring on a developer productivity or improve developer productivity and the CI. But just some background, it was a startup founded in 2010. It was originally written in Ruby, and it has grown to become a very large monolithic code base, mostly JRuby. It has quite a sizable portion in TypeScript and a growing number of files in Catlin as well. Originally, the developers were mostly working on macOS. CI system was on Jenkins, on Linux. Since the acquisition, we've all had to migrate onto a Linux distro kind of managed by Google. So it's just, yeah, it's like Debian-based, but not really. Cool. Yeah, so that's kind of just on the slide. You'll see just the mishmash of different technologies we had to support. This is important because we needed a tool that didn't just work really well for Ruby, a tool that didn't just really work for Kotlin, so we had to solve, how do we solve everything? And at the time we did adopt Nix, we had some influx developers working on macOS as well. Cool. So this was a slide that I actually developed when I tried to sell Nix internally at Looker. So this is a very, very, very old slide. The text isn't really important. You can't even read it, oh God, on the right there. Okay, it's just from the README of our internal repo, so it's probably even better that you can't see it.
That's like page 1 of 20.
Yeah.
Yeah.
Yeah, page 1 of 20. It had actual like code snippets you had to copy and run. So it was a very complex README, bunch of steps. It had a choose your own adventure style. So it wasn't like, do this one thing from 1 to 20. It had branches because, startup people bring their own opinions to things. So people wanted to maybe use RVM or RBenv. So those are different Ruby version installation managers. So I don't know why we wanted to support both, but we did. Same thing for Node. So it was pretty complex. You needed sudo at a lot of points in the script, which made it a bit crazy. And really, we didn't have any metrics for this because why would we? But it took an average developer anecdotally about a full day to go through it. With a lot of hand-holding, startups we had a Slack, it was a lot of engagement. People would run into whatever kind of like error from the day and someone would help them and people were really engaged. And to be honest, that sounds like a bad system, but it worked for like 10 years. So, because it was a small company and everyone was like really into it. So yeah, it kind of worked well enough. So I don't know, the engagement was almost like a feature and not a bug of this like shitty development process. So yeah, I just wanted to kind of highlight like this kind of worked. Like it was really bad, but it worked. And it had enough collective fixes on all the scripts to account for all the like weird edge cases people ran into.
Right on. Okay, so Farid did a lot of work and groundwork to research Nix. He kind of liked it for its intellectual purity. He liked it for all of its nice properties. And he kind of socialized within the team that like we could use this thing. It's mature enough for what we want to use. And at some point, we got the go-ahead to staff a small project for a bounded amount of time to accomplish something. And so I was a member of that effort where we just had a couple of months where we were going to do everything we could to like bring our build system forward and meet some of these goals. So we had a goal to like make sure that our CI system and the developer workstations were consistent. They were very much not before we started. We made a goal to speed up that developer workflow for like actually starting when you have a new developer and getting through that README faster. But we stopped without setting the goal of making the product itself be built by a Nix derivation. So we really invested in setting up a Nix shell environment that could replace the developer workflow in which we could build our product. And then we left open the door that we could continue this work in the future if we want to go ahead and make a derivation that builds our final artifacts. But we went 2/3 of the way through this set of goals and declared success because we had actually delivered a lot of value there. So next slide is going to just show kind of what we did on each of these goals. I'll verbalize it because I want you to have in your mind what we did before we go through all of these highlights and lowlights. So step 1A was that we set up Nix shell, a shell.nix that pulls in all the dependencies that a developer needs to run the build, as well as durinv, which manages setting the path whenever you switch in and out of that directory. It pulls in all of your Nix store paths and then throws them away when you leave. So it's a really fast in and out. Then the second bullet there is that we put this block of code in our CI jobs so that they also pull the same sort of Nix shell environment before running any of our legacy scripts. This is a big deal because we didn't want our users to really even necessarily know that Nix was happening, because there's like 100 developers. They don't know. We don't want to teach everybody the workflow of Nix at once. So we try to make this as invisible as possible for those users. All right, then the next big category of speeding up the developer workflow, that was a huge success because it used to be that everybody's developer environment started by downloading a JVM, downloading some version of JRuby, some version of Node, some version of NPM, installing all the dependencies that are driven by NPM, installing all the dependencies that are set by your gem file, installing all the dependencies for Gradle. There's just like this long list of work that happened on entry into a developer environment. And now all of that gets done by a CI job that populates a binary cache. So an engineer, when they like boot up a new cloud top, change into their directory, it just pulls down a bunch of binaries from a local bucket, and they have a shell within seconds or maybe a minute the first time. So it really did speed that up.
One day down to a couple minutes, pretty good.
Yeah. So as a percent speed up, it was like kind of a nonsense number, but like a thing that used to take all day now is something you can do routinely. Yep.
Okay, so things become a lot more interesting when you consider CI jobs. I mentioned we work at Google. Like, there's always some crazy bazillion flop numbers that are attached with that company's name. I wanted to give a sense of scale. Like, we were a startup, got acquired. What was the scale of the number of CI jobs we wanted to support? Like, the system had to support that. So this is a graph. It is, I don't know if you guys can see the number. I'll just tell you anyways. It's about 1,500 pre-submit, which is like the CI jobs you want to run on code review. We have a bunch of other jobs as well. They're not included in this graphic. So that's the median. And
The concurrent CI jobs.
concurrent CI jobs. And it's a pretty bad median. It's across like the whole month or whatever that time range is. Obviously, it like dips on the weekends because we have lives and we don't like to work on the weekends. But that's kind of the scale we were working with. And to be honest, that scale, we did hit some roadblocks. Like, I don't know if any of you were here yesterday trying to do the Nix Install Fest. There was quite a lot of issues just downloading from GitHub and hitting rate limits. So we hit a lot of similar issues at this scale. So whatever you hit with 100 people, at 1,000, you kind of hit a little bit more. Yeah.
Yeah. So we leaned heavily on those binary substitutors, and Nix already had support for using an S3 bucket as a cache, and Google Cloud Storage has a mode where it emulates S3. So we set up a bucket that manages all of our binaries, and that thing can scale to any amount of traffic. So it doesn't matter if 1,000 CI jobs all boot up at once and all pull down the Nix packages archive, and they all pull down a JVM that's hundreds of megs, it's fine, right? GCS or S3 can scale to unlimited reads, really. So.
Yeah. One last point, our security posture means we cannot use the public Nix cache. So we had that disabled, which is maybe also a good thing, considering, I don't know if you guys were at the State of the Union talk and the cost of the Nix S3, to support the S3 cache. This slide, we could probably do this pretty quick. It's just like a timeline, just to see like what did adopting Nix kind of take at our smallish, medium-sized company. It was like a 2+ year. It starts at July 2020. That's kind of like the research phase, looking at like, can I even adopt this? A lot of hand-holding, a lot of white glove, mocking things out, kind of like tool by tool, getting slow people. Honestly, like the implementation part was pretty slow, quick rather. It was mostly the big problem was socializing it. So like getting buy-in, getting people to know what the heck's changing, like should we adopt this thing that's relatively niche? Yeah, and kind of like a final notable mention is a big problem point was I was trying to support Mac OS and Linux at the same time, and that was really hard. Like, and I'll talk to why in some of the lowlights, like some packages just became really difficult to support on Mac OS, notably Chromium, and which we had to pull into our graph. Okay, we're going to get into now the highlights and lowlights. This is kind of like the highlight is we did some pretty boring Nix. In fact, like we were talking, me and Micah at the hotel after having listened to some prior speakers and thinking we could have done actually a lot more fancy stuff. We didn't use any modules, not very like reusable. It was, what am I showing here? Like a shell. I mean, we went a bit fancy, and I don't know if you could read it. We used the like no CC, so it's a little smaller. I mean, it's a shell with some build inputs, couple of custom derivations, but like, that's it, really. So in terms of like fanciness, it's pretty low.
Yeah, but the thing about us was that you probably can't read it, but the return value of shell.nix needs to be an attribute set. There's a few attributes that name binaries that get pulled in and set in the path, and then anything else that you set as a value there gets converted to an environment variable. So this let us control the environment variables and the set of binaries in the path for the developer workstations. So it meant that like every engineer, whether they installed their environment today or 6 months ago, or if it was on a Mac when we were trying to support that, they would all have the same version of the JVM. They would all have the same version of Node, et cetera. So just being able to control the environment variables and the path and the binary path of this Nix store was enough. We don't need containers. We don't need virtualization. Yeah.
Simple primitive, highlight. Okay, in 2020, we chose not to use the experimental flakes feature. And we didn't find it an impediment in any way. That's kind of like what I'll say on that topic. There's a lot of back and forth on it. I don't know. We just stayed out of it. And it was a highlight. So that was a quick one. You want to do that one?
Right, okay. So here's another good and bad. We're calling it a lowlight, but it was so easy for people to add the name of a package to this one source file, a text file, and then every engineer would have that binary. It made it really easy for this democracy or chaotic team to like pile in everything. So pretty soon people are like, wow, I would love to have Chromium in my build. Oh, I would love to have an IDE in my build, whatever. So this thing grew, and the closure over all the things that gets installed got to be pretty big. So it was too easy to add things.
A bit of a Pandora's box that we got open. Okay, this one is like, I would give tech talks, and I'd explain what Nix does and how it gives you near perfect repeatability, reproducibility, you know, whichever one you want to say. And some of the engineers, their takeaway was pretty good, and they'd come back to me and be like, great, like I want now Node at whatever, some very specific version, and I want another one Node at this other version, and I want it with this patch, and I want it to link with this other version. And they're explaining stuff to me, and they're not wrong. Like, that's the problem. I spent a lot of time explaining to them that Nix can do anything. So they come back to me, and they're like, now they want the world. And I'm kind of like, fuck, like, you can have it technically, but it's just me and Micah, and I don't want to do this. So the goal was to really have one Nix packages for our sanity that we pulled from. And if we wanted to do all this other stuff, it meant really blowing up our transitive closure. So, like, I'm calling that a low light because I don't know, I'm still grappling with, like, how to tell people to adopt this thing without them coming back and saying, like, they want a bazillion things at very specific versions. You know, I guess the good part is you could give it to them, but I found it an impediment. That's fine, yeah.
Sure, yeah. So, okay, this is good and bad. We've repurposed an art that you've probably all seen before, but the issue is if you declare a dependency of a package that is defined in a particular Nix packages, and then later another package at another version is introduced, that thing may depend on different libc, different other things. So if you go ahead and try and pin like an old version of Ruby, a slightly old version of Node, a pretty modern version of Chromium, then you end up with like a really big binary Nix store. So it got really big.
Yeah, another lowlight was, you know, again, I mentioned we tried to keep it to one Nix packages, but we had to deviate it a lot of times. And what was also frustrating, many of the recipes aren't really reusable. So we needed to tweak, unfortunately, a few things. And it just, you know, we tried to contribute upstream changes so that those recipes were more reusable so we can adopt them. But I'll mention later, us pushing, moving ahead on Nix packages was kind of a challenge. So we had to often just copy out a derivation. So there was like a bit of repetitiveness in our overlay and Nix packages, which was also a bit of a low light. So that's kind of the, Nix packages was like huge and sometimes unwieldy.
Yeah, okay, another issue is we don't control the whole shipping environment of our product in our team. We were kind of asserting control over the build tools and the developer experience, but another team manages the Kubernetes deployments and the Docker container images and the way they get tagged, and we didn't have like end-to-end control. So we basically use Nix to set up the build environment. We build our binary artifacts within a Nix shell that's under our control, but then another team has their own processes and their own culture about like using Docker container images and GCR and whatnot. So it's funny, like we wanted to replace Docker in our development environment, but the operations team absolutely had no interest in that at that time and no appetite for it. So we kind of like, you could either use Docker to build Nix or you could use Nix to build Docker, but we ended up with like two teams each using it in the opposite direction. And that's a cultural problem. It's not really a technical one.
Yeah, that was an interesting learning lesson for me is shipping software is not always technical. And you know, we've seen Docker tools in a couple of previous slides here that you could build layered images, but they wanted to build their own Docker image, like they being this other group. And it's like, how do you get past that organizational problem? I don't know. We're still pushing past that. Okay, I'll do this one. It's a quick highlight, and I couldn't get a benchmark. So the top one is a benchmark of what our Nix shell took. It's like 6-7 seconds. That sounds good, but that's just like really long time. And you know what? Typically, normal developers are accustomed to changing a directory and it just being effectively instant. So 7 seconds, they felt like something's going wrong, and maybe worse if, for whatever reason, it starts building the derivation locally because it's not in the cache, or I don't know. They're the first ones to ever hit it. So like Durenv was effectively a necessity. Like I can't see anyone adopting Nix shell at their enterprise and getting people to use it without that as a complement. So yeah, I don't have the benchmark for it, but it's like as fast as a race car, near instant.
Yeah, let's just briefly explain what that does. When you run Nix shell, it parses Nix shell.nix, builds the closure, checks for things in the store. All of that work took 6 seconds in,
One time.
to do it once. So every time you were to like start a new terminal and enter into this shell, it's taken 6 seconds. So that's no good for a workflow. And Durenv is another tool that sets up a shell hook so that when you enter a directory by typing cd and the prompt displays, a side effect of evaluating that prompt is Durenv runs a shell script. That shell script takes a snapshot of the environment variables from the last time you were in that directory and restores them. So it means that if you have ever entered the Nix shell, the first time takes 6 seconds, but then any other time when you exit the directory and come back in, it's just changing some environment variables, and that happens like near instantly. So this is like, you lose the little bit of fidelity of your closure because you just have the environment variables, but it's totally enough. So that made a workflow. The workflow is great. Right. Okay, cool. Here's another thing. Nix actually stores some state in your home directory and in a database in the store. And not everybody knows like which environment variables might affect like the combination of the final calculation of hashes that become a cache key. So we just wrote a script that like installs Nix on your machine, and another script that blows everything away, including all the subdirectories where we know that Nix keeps state. And then that way, whenever an engineer says like, there's a problem with my build, it's not hitting the binary cache, we'd be like, no problem, just run this script. And it would solve the problem. So it's a big hammer, but like, it's so easy to go from 0 to having a particular Nix state that it's okay to just throw away the state and make it again. So I'm calling it a highlight. Yeah.
Okay, this seems like a simple one. Again, like nothing shocking in any of this talks, or our talk, but having the hash name, like those like squiggle, the cryptographic part of the name there, incredibly powerful. Like it made triaging issues with the other engineers very quick. I could just ask them to like, tell me the path, or tell me like, run the command which, whatever. In this case, it'd be Ruby or JRuby, and I'd see what they see. If it's different, I already can like take branch A. If it's the same, I've already skipped a dozen steps in my mental model of whether or not they have the same software as I do. So that just like that visual cue, huge. It also gave us a lot of confidence that the CI system was running the exact same software, and it was in fact hermetic. So we would emit the paths that we were running Ruby or Node, and know that yes, we're running, or the final closure, and know yes, everything's the same, and it didn't pick up some random nixconf, setting, or we forgot to set maybe, we were using like, anyways, yeah, there's a bunch of different like idiosyncratic ways which you can leak out some state.
Okay, let me take this one. Because Looker is an enterprise software, we ship a binary to some customers that they keep in the field for years, and then maybe years, and then other customers that we're giving updates every month, every week. So the fact that we were able to have our toolchain configuration checked into our same source code repo where our source is at means that if you need to make a small change to a year-old release branch, you just change that branch, make a patch, and all the binaries that go with that build are also in your path. So you don't have to remember that, oh yeah, that old version from a year ago only runs on an old JVM with a patch, right? Because when you switch your dev tree, shell.nix has that pinned Nix packages, and that's the JVM you get. So it made it like actually possible for us to keep building old branches long after, like even maybe if the source code that we needed from an upstream thing was gone, not hosted anymore, we could still build because our Nix binary cache is durable. So this was a huge lifesaver for supporting old release branches.
Yeah, this slide's made a rounds a couple of times, or at least twice, I think, in NixCon today. But few people understood Nix. Okay, I gave like, I don't know, a dozen plus talks at the company and at broader Google. And I don't know what the acceptance rate was of like what I was saying to what they were receiving. It'd be like under 10% for sure. And I think this graphic, which was shown a couple times, just a bunch of stuff about Nix doesn't lend itself to become easily understood. I'd say the word Nix, and right now it's like, what am I really talking about? I guess I'm talking about really all of it. And then if I wanted to talk about just the language, I'd say Nix. So Yeah, it continues to be confusing, and since adopting Nix, really, we haven't seen much increase in contributions from a few key people. So I think that's something to keep in mind, and I guess that was a low light. Some things we called out was like lack of good IDE tooling. I know the language gets a lot of flack, and it's not that bad after I've used it for quite a while, but having someone jump in, and it's difficult to navigate and understand the type system and find where things are. Yeah. I'll take this one. Okay, this was something I hit because I said we kind of hit like some edge cases here. So it's a bit of a snide comment about a real problem, but basically missing source files for particular old Nix package versions, such as patch files, could go missing. And large packages such as Chromium, are repeatable, so you could build them, but I couldn't build them on my machine. Like sometimes you'd need a massive machine to build it. So it's like, great, I have this recipe to reproducibly build software, but on whose machine? Like on the Chromium guy's machine, he could build it. I can't build it. And I know Nix cache does cache some of the source files itself, but I found a few cases where some patch file would go missing, and you get a 404. And it's like, okay, that's like, well, how do I rebuild this now? We were kind of in a sticky spot because, again, we were using a very old Nix packages, I don't know, over a year. So, yeah, and we couldn't use the public cache. So we were building things from source, relatively old, and missing some source files. I have certain environment variables were also found to have an effect on the computed store hashes. So we found like sometimes some developers would also miss the private binary cache that we rely on. Okay, I mentioned this one a bunch, but basically updating Nix packages, like I hated doing it, and I tried not to do it at all. I would never, I thank the release managers so much, but like that's an incredibly tough job, getting all Nix packages to pass. I don't know what we're at now. Like I look at that Repology graph, if any of you have seen it, it's like 80,000 packages in Nix packages or something like that. And like I said, when you have access to that, you just want to use more and more and more of it, so updating it. And then if you deviate a little bit, it becomes hard, so it was hard. So I resorted to using a few, I think we have like 3 or 4 Nix packages at different commits there. That turned out to be the easier problem, but it would pain me so much time, when I would do that. So yeah.
Yep. Let me take this one. The picture shows basically the 3 nesting dolls because we had these abstract environments that we only controlled between Farid and I, this middle one. On the outside, we have this G-Linux distribution that another team controls. We control the Nix shell of our build environment. But then inside our Nix shell, we run other build tools like npm and go out and get things that developers have declared dependencies on. So we were able to like grab intellectual control of that middle layer and deliver a huge amount of value for it. But like the rest of the nesting is like still somebody else's domain. So it's a highlight because we were able to like actually work and add some certainty to that middle layer, even without controlling the outer layer. We also got to do this in our CI jobs that we don't have root on the CI machines. So being able to install user space binaries in a controlled way, super big highlight.
I think it's also a highlight, like the developers didn't have to change their workflow. If they used Bundler or Gem or NPM, that stuff, pretty much worked. And as Z would say, asterisk, like there was some finer points, but for the most part, they didn't know they were using Nix, and that was a highlight.
Yeah.
Okay, this is one of the, maybe the last slide. I'm calling it a low light. Like my experience in Nix packages and ecosystem was like mixed depending on which path you take. So like not all languages and frameworks in Nix packages are created equal. It is an open source project. So it's like subject to contributions and what's there and passion of the developers that are contributing to it. So I found like C++ and Haskell, phenomenal. Like, if you want to build a Makefile project, like you're not going to have a bad time. If you're doing Haskell, I don't really do Haskell. It looked phenomenal there too because there's a lot of overlap with Nix. We were doing Java. Like JRuby is built on Java. Like there was the JDK there, but it had a lot of bugs. There was like packaging a Java app. I wanted to look at it. Not really supported well. Had a bunch of weird kookiness to it. So like, yeah, that was, I'm calling it a low light because I didn't know that going into it. It kind of felt like it had everything and some panacea, but nothing ultimately was a blocker, and I upsourced a bunch of changes and fixes, so that part was a highlight. It just meant, like, be mindful about which path you're taking and what language you're doing. I think see what's out there and yeah, know what you're doing. I could read some of those to-dos.
Right.
This is like, we have a bunch left to do. It doesn't matter if you can, I don't even know if you guys can read what's on the screen, but like we mentioned, we have a bunch left and we got a ton of value. So like even with all this laundry list left to do, what's some of the stuff there? It's like,
probably the big thing is getting Nix and Bazel integrated. Like the talk we saw this morning was really, or earlier today was pretty great because we also use Bazel in our build, but we use Nix to install Bazel and control its environment. And I know it's possible to invert that relationship, and it's a different thing, but we would like to continue that and get all the way down to the end of those leafs.
And maybe overcome that organizational problem, get them to use like a Docker imagery build. So there's like a bunch left, finally get Nix packages on the latest release, like things like that. But yeah, still huge benefit.
Yeah, that's the point. Like even though we only got halfway, it's still valuable, and the team values it, and it works every day, and it doesn't crash.
Cool. That concludes our slides. Happy to take whatever time we have left for questions here. Otherwise, please find me or us. I'll take a couple, or we'll take a couple. You got okay? Couple questions? Oh, okay. We'll start at the front.
So, did your developers ever get asked just like adding things like build inputs for the tools they wanted, or did they ever become like Nix fluent?
Okay, so he asked if the developers got Nix fluent, and I would answer basically a few. There were like 2 or 3 people who like needed to upgrade a package and then had to get deep into the recipe to make it work. But most engineers, they just got trained to like type this one command, and then your shell is good.
2 out of 100. So take that as your percentage.
Yeah.
Okay. You and you. Point at yourself. I don't know. Yeah. Yeah, that's a good question. The thing we did had to articulate is it's a pretty simple solution because it's all environment path based. You had to start your IDE in the next, like in your current working directory. Yeah, so, thank you. How did we solve IDEs, integrated development environments or text editors, to use all this like fancy Nix stuff? And basically, as long as you start the IDE within the shell, within the directory you're in, it picks up the environment as a subprocess. So it'll find all the tooling from the path Nix sets up. The one hiccup here is if you change to a really old branch where your path changes, like you'd have to know to shut the IDE down and reopen it. So that was a bit of a pain point, but otherwise it worked pretty well. Over there.
Yeah, I guess the short answer I can come up with, he asked what happens if the few experts in the team that know anything about Nix, if we're all gone, then how would the company continue? And the short answer is that all that code is checked in. It's in our repo. The CI system, will not allow you to check in changes that break the test. So like somebody will have to figure it out. Like,
I can guarantee it'll keep working. Like that's a selling feature. It won't degrade. It may not get better, but to answer your point, like seriously, like, we haven't seen much more adoption in terms of people using it, but also we haven't had to change it much. So like once it's hit stability, the big thing's been keeping Nix packages up to date, and yeah. Okay.
this guy in the brown pants, I saw you had your hand up right away. Yeah. Yeah. Yeah, so the question is like, how do we avoid accidentally depending on something in our build environment that's provided by that G-Linux layer, and then breaking the hermeticity? The short answer is that our CI system doesn't run on G-Linux. So if you ever introduce some shell script that like makes a call out to some awk binary that is absent from our Nix closure, then that will fail the CI jobs that try to build the Nix closure. So.
Yeah, and just to be clear, we're not in like Google's mono repo thing or any of that. So we're yeah, it's a separate Git repository. So that also helps. Okay, okay, so we'll do two more. You with the white shirt, the NixCon shirt, yeah.
Okay, he's asked about the Nix Bazel integration. The short version of it is our Nix environment installs Bazel, and it also downloads all of the HTTP archives that we know that our Bazel workspace file references, and it puts those into a directory so that the first time you launch Bazel, it has a JVM, it has all the Starlark rules it needs, stuff like that. But then Bazel just drives our regular Java build and produces all of our JVM artifacts that then get wrapped up by shell scripts.
Yeah, I'll just add the part it really shines for me is Bazel and tool chains is like their tool chains. If you've used Bazel, their tool chain solution is pretty terrible. That's a personal opinion. So it's a great way to bring in like if you want Clang, the JVM, whatever. It helps that tremendously. Last question, Mask.
So I want to say the solution that y'all came up with of just using the shell and everything, really genius. I tried to get Nix adoption in other previous employers in different environments, and it's interesting to hear that'll work great for y'all. I'm curious, can you elaborate a little bit about the difficulties that you found with, you mentioned that Java, Ruby, JRuby, had difficulties with, and I would actually expect that, I would expect that from like trying to build something as a derivation, but it sounds like y'all are using that for shell. What would it sort of
Yeah, can I take that one? I'll do a simple example. It should be pretty quick.
Restate.
Sorry?
Restate the question.
Oh, restate the question. Frick. Okay, yeah. What are some of the issues we ran with JRuby, Java? You would expect that maybe with building derivations, but not with maybe a Nix shell. The one that really comes to mind is the Nix package contributors have done a really good job cutting away like system state. Like, so, I don't know, the loader is patched away so it won't read user lib, like shared libraries, things like that. So there's a lot of like patches to make things so they're hermetic. The JVM was missing a few, and they would come to bite you. So if you had to use Java can do native interfaces and link to shared libraries, I found it linking to like a different libc, and then suddenly you're hit with a seg fault. So nothing like we couldn't get over, but you're just, again, it's like those two paths I showed in the slide, like, oh God, like, why am I hitting this error? And it's like, you know, you're trying to triage it. So it was mostly shared object calls and, yeah, path leakage. Cool. We only had, anyone else has questions, please find us at the unconference or outside. Farid, and that's Micah. Thank you so much.